Assalamualaikum and hello to all the viewers and panel of my video presentation. My name is Mohamed bin Azahar. The purpose of I am doing this video is to present about my first final year project of MEC601. The title of my FYP1 project is Effect of Heat Source Model on Substrate Deformation and Thermal Distribution of Wire Arc Additive Manufacturing by using Numerical Simulation. My supervisor is Professor IRTS Dr. Yupiter Harangan Prasda Manurung, and my co-supervisor is Siti Nursyahirah Ahmad. First of all, let's start with project summary. This research study is focusing on discover and analyze the heat source model for wire arc additive manufacturing. The model of WAAM will be built in numerical simulation software, and the heat source model will be developed with user-defined well subroutine. After that, a numerical simulation will be implemented to analyze on substrate deformation and thermal distribution on the selected source model. At the end of the research, result of substrate deformation and temperature distribution will be compared between two different heat source models. Introduction of the project. Additive manufacturing (AM) is a technique by which free-form structures are created layer by layer fashion by building up content. One of the process of AM is wire arc additive manufacturing, which is it has the ability to produce and manufacture large custom-made metal workpiece with high efficiency among the different AM process. For this process, the related thermal analysis start with the solution of heat source, a suitable form and distribution of heat strength, the metallurgical microstructure, chemical modification of the material, dual pressure, hardness distribution, thermal cracking, thermal shrinkage, and heat affected zone (HSZ) will be affected by the distribution of temperature and cooling rate near the surface. The implement of FEM process simulation will arrange an appropriate manner to research changing positions for some problem. Literature review. There are three sections in this literature review, which is wire arc additive manufacturing, finite element method, and AISI 316 stainless steel. Wire arc additive manufacturing. Over the years, for the manufacturing industry, additive manufacturing became one of the huge and extensive innovation in the production of metal parts. Additive manufacturing is method of joining material to create components from 3D model data, typically layer by layer, which has seen substantial rise in research and development since its arrival in the manufacturing sector. And a technology have a capability and potential to lessen the cost by reducing the wastage of the material and time to market. Wire arc additive manufacturing is one of the most effective AM process and a promising alternative to conventional subtractive manufacturing with buy-to-fly ratio is higher, and it's enable the creativity in designing freedom and reduce the limit for manufacturing of complex assemblies formerly made of numerous subcomponents. Process of WAAM will utilize gas metal arc welding process, where the wire is made by an end arc plasma heat supply. Finite element method. In the 1950s, engineers, especially in the aerospace field, began to use finite element method (FEM) more commonly. Just a few exclusive groups could access the technology, as modern computers were already not commonplace and were very expensive. The utilization in manufacturing process of the FEM is now well known. It is increasingly used in development process and is part of the area of emerging application for computational mechanics. The industrial need to improve the quality and efficiency of product and to have a good understanding of the effect of various process parameters is the most important reason for this growth. Model phenomena play an important role in the manufacture of steel products with different levels such as heat treatment, welding, and casting. MSc Mark method is the advanced software function for non-linear finite element, has a good structure for research capability, and can accommodate for a range for linear and non-linear structure analysis. The software will be used in this research. Stainless steel. WAAM can generate parts in longer moment. As an effective tool, this system uses electrical arc to freeze copper wire and can achieve a broad feed rate. Due to their superior performance and economic expense, stainless steel are commonly recognized as a significant class of alloy. Stainless steel alloy have a chromium content of at least 11%, and the presence of chromium essentially avoid the production of rust. Stainless steel are also commonly used in the industrial manufacturing. Long service life, efficiency, correct mechanical properties, and the applied aspect are the key considerations. Stainless steel, which have high strength and ductility as well as strong corrosion resistance, have been used in unique conditions as critical structural material. Problem statement. In WAAM, the design consists of a sequence of single-welded structure, one of the most rotating create with division measure. The problem statement is how the effectiveness of the recommended modeling and how the simulation of the finite element method offer an efficient manner to research modification basis for this issue. And for the objective for this research is to determine the parameter of wire arc additive manufacturing model by using 316 stainless steel. Second is to generate a simulation model using MEC601 as FAM software for comparing two different heat sources. The last one is to characterize the substrate deformation and temperature distribution induced by WAAM process by using two different heat sources. Scope and limitation of the project. First, this project will be focused on substrate deformation and thermal distribution. Next, it will be perform simulation analysis by using MEC601. And the last one is the compare result of substrate deformation and temperature distribution between two different heat source models. Next, we will continue with the methodology of the project. Here is the flowchart of the project. It will show the flow of the project until the end. First of all, determine the problem statement, objective, and scope of the project. Next, a literature review will be formed based on the related topic of the wire arc additive manufacturing. Next, determine the important parameter of heat source model regarding by the research. Next, build the model of heat source by using MEC601 software. And then the simulation will be run. Next, comparing the data of the heat source model. And the last one is prepare the result, discussion and conclusion of the research, and the project will be end. This is the flowchart for numerical simulation procedure. First of all, geometrical modeling and FEM machine. Next, selection of the material. Next, define the contact body and interaction between elements. Next, determine the filler metal with path and orientation. Next, define the initial and boundary condition. Next, the case setting. Next, check and run the simulation of WAAM. Last one is analyzing the result. Geometrical and material modeling. These geometries will consist of a table, a base plate, and a multi-layer weld bit. This is the heat source model for this research. The study of boundary is split into thermal and structural analysis in simulation. In every section of the boundary condition on both solid model and the shell model, the thermomechanical parameters are defined. The boundary condition of heat source model is set when assigning volume wet flux in thermal structural analysis. The ellipsoid by Goldberg and rectangular heat source model had been chosen as the heat source for this simulation. Double ellipsoid heat source model are two elliptical regions in the heat stream, one in front of the arc and one in the center, and were commonly used in GMAW welding process. The geometrical parameter A, B, and C of double ellipsoid heat source model and the value are independent, that can be changed into another value of the rear and front quadrant. For rectangular heat source model, the user-defined U-weld flux subroutine which had been modified will be applied in the MEC601 code with the uniform distribution of heat intensity of various heat source. Last one is the expected result. First, to accumulate the finest model of simulation that will yield comparable results for both heat source. Be prepared to achieve a satisfying outcome in monitoring the sample and the specimen mechanical characteristic. Next, be able to determine substrate deformation and temperature distribution induced by WAAM process using two different heat sources. And last one is have a better understanding how different heat source model on wire-up additive manufacturing works. This video will show how the numerical simulation works on this model. So that's all for me for my video presentation for the final project. Thank you for watching. See you next time.